The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke two seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. there are only two confirmed active volcanoes in Antarctica: Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger. The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen Volcano Mega Tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega tsunami. The Vajont Dam Mega Tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens Mega Tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay Tsunami. A landslide caused by an earthquake creates a megawave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan Asteroid Tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega tsunami, the largest in Earth's history. The first waves almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka Earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso Earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku Earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot high waves that travel 6 miles inland. Indian Ocean Earthquake, Sumatra. A rupture along 2 tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half inch and sets off earthquakes all over the world up to Alaska. Good Friday Earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean Earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno Tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville Tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels 2-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moor Tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam Reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoi Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoi Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long.
Back in the day, from 774 to 775, Earth got hit with a mega blast of radiation. This crazy burst of energy left its mark. 3 rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast. But astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. After looking at the radioactive carbon and beryllium in tree rings, scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants. Sorry. Later on, they found this huge hole that was like 23 feet wide and nearly 65 feet deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon. Summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show. A bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech. Because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty rough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. And it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 1,800 miles per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now, listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms, like the Carrington event, and take notice. Imagine if a similar storm hit today. An internet apocalypse, anyone? Businesses would be sent offline and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit?
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a super volcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems, those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today. Rocks rolling down the slopes of a rumbling volcano, pushing other bigger rocks on their way, and eventually tumbling down into the ocean in a humongous cascade, causing a wave the height of which the world's never seen before. This is what might happen if the Helena slump of the Hawaiian Big Island falls off into the water. The Kilauea volcano is far from dormant. The latest eruption occurred in 2018. Its eruptions are usually accompanied by earthquakes of different magnitudes, and with each quake, the magma rocks on the slopes of the volcano shift down. These rock formations are called slumps, and the Helena slump is the most notorious of them all. In 1868, the shift of this slump caused a tidal wave rising as tall as 60 feet. But what's most troubling is that some 110,000 years ago, a landslide here led to one of the most powerful earthquakes ever, which in turn led to a mega tsunami of over 1,000 feet in height. Scientists are worried that such an event may repeat in the future. If that happens, the wave might engulf the whole of Hawaii and easily reach both North and South American coasts. Geologists are quick to reassure, though, that a landslide like this is unlikely to occur anytime soon. It's just too early for that. But when it finally does, the consequences will be catastrophic. Have a nice day! Yellowstone National Park in the western USA is world famous for its dazzling views, and especially the colorful Grand Prismatic Spring at its very heart. But we should all stay aware that Yellowstone is, first and foremost, an enormous caldera, basically a slumbering supervolcano. The difference between a regular volcano, like Kilauea from earlier, and a supervolcano is that the latter is thousands of times more powerful. Imagine an eruption spewing tons of huge rock and rivers of hot lava, pumping out clouds of ash that make countries stop air travel for weeks. And now multiply all of this by 1,000. This is what a Yellowstone eruption would look like. At first, a huge area in the middle of the national park would shake, crumble, and then blast upwards in a megaton explosion. Lava flows and magma rocks would cover the area of about 40 square miles, roughly half of Washington, D.C. But the greatest danger is the volcanic ash. The ashen plume would rise miles above and get carried by the wind in every direction. Since the eruption would be far from ordinary, the spread and damage would also be much greater than usual. The ash is thick and heavy, so it would cover a vast area in a blanket, destroying crops and even buildings. Worse still, it would spread in the air and block out the sun, leading to a drastic drop in temperature and an artificial winter. Even regular volcanoes can lower temperatures worldwide by a few degrees. A supervolcano may potentially cause a new ice age. Luckily, the chances of Yellowstone supervolcano erupting in the near future, or at all, are extremely low. There have been only 3 of those in the history of Earth, and there's no evidence such a disaster should repeat. Scientists estimate the probability at 0.00014%, which is lower than the chances of an asteroid wiping us all out. Speaking of which, if dinosaurs could talk, and were at least still alive for that matter, they'd tell you that asteroid threat is as real as it gets. Scientists at NASA say they've tracked 90% of all near-Earth asteroids of significant size, and none of them are a matter of any concern. But there are still the other 10% in the great unknown. What's more, asteroids can change their line of flight because of the pull of other celestial bodies and eventually turn our way. Lucky us! Now, if an asteroid big enough, like a mile across, hits the Earth, it will first cause an explosion powerful enough to erase a dozen big cities in a matter of seconds. Then the impact will raise a cloud of dust and debris that will block out the sun, just like the ash cloud from a volcano, and cause a centuries-long winter on the whole planet. But even if it falls into the ocean, which is more likely, a resulting wave will rise several miles high, washing coastal cities off the face of the planet. But at least there won't be a new ice age. Although scientists are pretty sure there's no such threat in the near future, it can't be ruled out completely, and humanity needs at least 5 years to prepare for this event. If a big near-Earth asteroid suddenly changes its course and turns right toward our planet, we won't stand a chance against it. Disaster movie, anyone? A much more probable calamity, though, rests right beneath our feet. It's the San Andreas Fault in California. The fault has been ready for rupture for years now, and scientists estimate that an earthquake along this line is likely to occur in the next 3 decades. And when it happens, it won't be nice. They expect a magnitude of 8.0, which is comparable to some of the most devastating quakes in history. It's all the more dangerous since California is home to some of the most populated cities in the western U.S., including Los Angeles and San Francisco. High-rise buildings are common there, and they're particularly vulnerable against underground shakes. The San Andreas earthquake might cause a whole lot of damage both to cities and countryside. In the worst-case scenario, the ground might break apart, destroying buildings, farms, and changing the landscape altogether. Still, scientists believe that the probability of such a quake is only 7% for the next 30 years. So, there's a rather big chance, 93%, that we'll never see that in our lifetime. Yet, there's another earthquake hazard not so far away from the previous one: the megathrust in Chile. The country sits right above the subduction zone, an area where 2 tectonic plates meet and go one beneath the other. At the place of their meeting, stress has accumulated because of their continuous movement, and once that strain is too much, a major earthquake occurs. Chile has experienced a lot of quakes in the recent years, and scientists are worried those might be preparing the area for a really big one. They believe a great earthquake is due to happen before the end of the century, and it might be devastating to the coastal area. Even smaller quakes cause tsunamis that flooded the west coast, and a huge one like that is likely to raise a wave of incredible height. On the bright side, Chile now knows to prepare in advance for the coming natural disasters, and geologists are pretty sure people will be able to evacuate before the earthquake strikes. In September of 1859, astronomer Richard Carrington was looking at the sun and suddenly saw a bright flare on its surface. He made a note of it in his records, but only realized how important it was a couple of days later. The energy from that flare reached Earth and struck it directly, causing northern lights to appear above Cuba and burning telegraph lines all around the world. This was dubbed the Carrington event, and it was a solar storm. Such storms hit the Earth fairly often, but none of them were so powerful as the Carrington event, neither before nor after. But in 2012, astronomers registered a similar solar flare whose energy nearly hit our planet once again. If it had been just a week earlier, we'd have been in big trouble. Today, humanity relies on electricity in almost every aspect of life, and a powerful solar storm would mess with the electromagnetic field of Earth a lot. All electric appliances would either shut down or short-circuit, and huge transformers powering basically everything would go out of order for good. It would take years to repair them, and the cost of such a massive blackout would count in trillions of dollars. The worst of it is that science is almost unable to predict solar storms, and even if we could know about them in advance, we'd be powerless to stop them. The flare happens in a matter of seconds, and it takes about 8 minutes for the particles to reach the Earth's atmosphere, causing the disturbance. The power outage would come a bit later, in a day or so, when a massive cloud of plasma gets to our planet. At the moment, there's no protection against solar flares, and the chances of one powerful enough to cut all of our electricity in the next few years are quite high, about 12%. The only good thing about all this is that we now know of such a possibility and can at least prepare in advance. Hey, don't forget to pack some underwear and socks. You'll always need those.
It's one small step for man, giant leap for mankind.
In the late 1950s, everyone was captivated by space exploration. But there was a group of rebels who wondered not what's out there, but what's down there. This team called themselves the American Miscellaneous Society. Yes, that's their real name. and they started one of the biggest projects ever, Project Mohole. Joyful and determined, they had no idea what a nightmare they started. First, let's understand what the project was about. You probably know that Earth is like a giant onion. If you cut it in half, you'd see it's made of layers. Each one is different from the next. The crust is what we all stand on. It's incredibly thin, like the skin of an apple. It's made of tectonic plates, almost like puzzle pieces, and they float on the layer beneath. That layer is the mantle. It's mostly solid, made of rock, but these rocks flow and move very slowly, just a little bit over thousands of years. They're also incredibly hot, thousands of degrees Fahrenheit, so it's a bunch of scorching stones moving around like caramel syrup. And when the mantle moves, the tectonic plates above move as well. Usually, this movement is slow and harmless. We don't even notice it. But sometimes they can bump into each other, get stuck, and so on. And when they do, they send such horrifying vibrations through the ground that they're hard not to notice. These vibrations are called seismic waves. In 1909, a Croatian scientist, Andreas Mohorovičić, noticed something weird. Turns out, at a certain depth, seismic waves suddenly speed up. He didn't yet realize that he stumbled upon a boundary between the crust and the mantle. It became known as the Mohole boundary. Now try to guess what the Project Mohole guys decided to do. It was during a meeting of the National Science Foundation. Everyone was discussing current scientific progress. Suddenly, Walter Munk, a geophysicist and oceanographer, casually threw out a take that shocked the room. Why not drill all the way down to the mantle? His idea was outrageous. Drill through the ocean floor, deep into the planet's skin, reach the Mohole, and see what it's all about. Never mind the fact that the ocean is crazy deep with crushing temperatures and violent currents. Super bold, but not entirely out of nowhere. If we start from the ocean floor, the Mohole lies just about 3 to 6 miles below it. It's much easier than starting from land. That would require digging from 10 to 60 miles deep. That made the oceans the best bet for reaching it. Munk wasn't the only one. Harry Hess, one of his colleagues, was just as excited about the time. At the time, people didn't know much about plate tectonics. Hess was one of the founders of that theory, believing that the world is made up of giant moving plates. To him, it was great. Drilling to the mantle would give him evidence to prove that theory. They became a team and found more like-minded scientists. They combined the most brilliant minds in earth science: Roger Revelle, Maurice Ewing, and Arthur Maxwell. They called themselves miscellaneous because there were all sorts of scientists in the team. Poor guys didn't know that their playful name would later come back to haunt them. But the NSF was dumbfounded by their idea at first and rejected it, because duh, it would be a nightmare to pull off. So our team secured $50,000 just to make a plan. Then they presented the official banner. Luckily, science was on the rise, and there were rumors about other countries trying their own deep drilling projects. So the AMS got the green light this time. The plan consisted of 3 phases. Phase 1. Do a drilling test. Check how things are going. Phase 2. Build an intermediate drilling vessel. Phase 3. Keep going until they reach the Mohole. And they got a funding of a whopping $2.5 million. And finally, in March and April 1961, the project finally began. Phase 1 took place off the coast of Guadalupe Island, Mexico. They used a converted barge called CUS-1 and some insane brain moves to make it work. Originally, CUS-1 was made for drilling oil offshore. It was one of the best things we had for drilling in deep water. But a catch was that it could only go a few hundred feet down. And remember, we need at least 3 miles. The team had to come up with something revolutionary: dynamic positioning. It's a tech that allowed the ship to stay perfectly still in the middle of the ocean, even without an anchor. It worked like this. They dropped 6 buoys into the water, forming a circle around the ship. These buoys sent underwater echoes to help the ship understand where it's located. Using motors and a joystick, the crew could keep Cuss 1 right in the center of the circle. And surprisingly, they started making progress. Even though ocean drilling is incredibly hard, they drilled through thick layers of sediment and reached an astonishing 600 feet below the seafloor, about 2 Statues of Liberty. And the seafloor itself was almost 12,000 feet deep. This was just the beginning. Deep down, they stumbled upon tons of basalt, a type of volcanic rock. It doesn't surprise us now, but for that time, this achievement was groundbreaking. Turns out they got through Miocene-age sediments, rocks formed millions of years ago. This discovery told us so much about the history of our planet. Now the entire world held its breath. Even the famous writer John Steinbeck, the author of East of Eden and The Grapes of Wrath, got caught up in the excitement. He joined the project and wrote a dramatic article about it for Life magazine. He wrote that we knew less about the ocean floor than we knew about the moon. That line stuck. The biggest surprise was that President John F. Kennedy sent a telegram congratulating the team. It's like the space race turned into inner space, and for a brief moment, it looked like they just might do it. But years later, Walter Munk said that the very success of Phase 1 doomed the project. The early triumph raised expectations sky high. From the start, the miscellaneousness of this society led to tons of disagreements, logistical hurdles, and the costs just kept rising. When the NSF realized just how successful the project was, they took over in 1961. The original society became just an advisor, and this completely screwed things up. One of the scientists said that it was a lengthy and unattractive trail of bickering, bitterness, and short-sightedness. They wouldn't even decide what exactly they wanted to do and whether they even want to reach the Mohole. After that, the project found the new contractor company, Brown and Root, but it was a political decision, not a scientific one. Brown and Root had no experience in deep-sea drilling at all. Poor scientists had to suffer because this company didn't understand the project's goals and how hard it is. Some scientists even quit because of how annoying that was. As a result, when they calculated how much it would actually take to reach the Mohole, it turned out to be about $1 billion by today's standards. This shocked absolutely everyone. The public was mocking them, which didn't help at all. Some articles called it Project No Hole and gave titles like How NSF Got Lost in Mohole. The final blow happened in '66. The project's most loyal supporter, Albert Thomas, passed away. Plus, the situation in Vietnam was escalating. As a result, the project was stopped after eating up tens of millions of dollars. What's even worse, this giant, impossible idea took the funding from smaller and achievable things. But it wasn't entirely for nothing. Project Mohole pioneered a new deep-sea drilling technique, which is now standard. They also inspired many new, similar, smaller ideas. And science just kept going since then. In May 2023, scientists finally achieved this dream. They actually pulled up rocks not even from the Mohole boundary, but from the mantle itself. They got them from the bottom of the Atlantic Ocean. So maybe one day we'll be able to drill all the way down there. Closing the North Sea in a nearly 400-mile-long dam may save Europe from complete disaster. This is not some sci-fi stuff. It's real. And it's called NEED, Northern European Enclosure Dam. It's a last-ditch plan to save over 25 million people from 15 European countries from the rising sea levels. To build this giant bathtub, humans need one dam between England and France, another one between Norway and Scotland, 51 billion tons of sand, and almost 600 billion euros. As crazy as it may sound, this project is totally feasible, except for one teeny tiny detail. The scientists who had this literally life-saving idea don't want the dam to be built. First and foremost, the NEED needs, two dams. One that is 100 miles long and almost 334 feet deep in the English Channel, and another that is 300 miles long and more than 1,000 feet deep in the North Sea. Building something like this requires a crazy amount of materials, like the 51 billion tons of sand we mentioned before, which is basically all the sand everyone on the planet uses in a year. And yes, this dam would obviously be the biggest in history, smashing records like the Netherlands' 19-mile Afsluitdijk and South Korea's 20-mile Saemangam seawall. The Need Dam would be 19 times bigger than Saemangam. It sounds ridiculous, but it's not impossible. You see, humans are pretty good at building big stuff. Oil rigs, for example, operate at depths of up to 6,500 feet, and the Need Dam would only go down more than 1,000 feet. Plus, China has a 102-mile-long bridge, and the dam would only be 4 times longer. Besides, projects like this dam were done before for the exact same reason. It's our friend Afsluitdijk in the Netherlands, which was built almost 100 years ago. The idea here was to shut off a part of the North Sea called Zuiderzee and protect the Netherlands from all the flooding because most of the country is below sea level. They even drained one of the lakes formed by the dam and created a whole new province, Flevoland. Today, the Netherlands has more than 2,200 miles of flood protection, but it's only designed for a 15-inch sea level rise. Without it, the country would be underwater. So yeah, we could do it, but it's really expensive. How expensive? Well, it would cost around 550 billion euros if the project is wrapped up in about 20 years. One wrong step and humans can spend 100 years building this dam, and a couple of billion euros more. The good news is that this much money can be diluted over the 20 to 100 years it takes for the dam to get finished. Besides, the 15 countries it would protect could share the expenses, reducing the amount to only 0.1% of the GDP of all the countries. Not a bad deal to save millions of people, right? Okay, but is this monstrosity really necessary? Well, unfortunately, humans have managed to turn the ocean against us. This means that by 2100, the sea levels are expected to have risen between 1 to 2 feet. If we keep acting like it's none of our business, the rise can reach more than 16 feet by 2300. It may sound like a distant future, but NASA has just discovered that the ocean rose way more than they expected in 2024, which means global disaster is breathing down our necks as we speak. Let's go back to our geography classes for a moment and learn why sea levels are rising altogether. First, because land can sink. The city of Norfolk, Virginia, for example, was built inside a massive crater, and the earth there can erode and sink. Then the soil can get compacted. Because of that, the city is literally sinking into the ground, making it more vulnerable to flooding. In California, some areas are sinking too, but this time it's because of the movement of tectonic plates. Some of the land that is underwater goes up, some of the land over the water goes down. The consequences? Again, heavy flooding. Sea levels also rise if the planet gets too hot. This happens because of a thing called thermal expansion. It has a very scientific name, but it basically means that things like water get bigger if the temperature rises. Half of the reason why sea levels are rising is because of this. This is why the level of the ocean increases almost 10 feet every time the average temperature of the planet rises by 33.8 degrees Fahrenheit. Since 1880, the sea has risen more than 8 inches. Okay, so we build the Need Dam and the problem is solved, right? Well, building this dam comes with massive consequences. First, the ocean currents, think of them as underwater highways that deliver nutrients to tiny creatures like planktons, not the SpongeBob villain, and give rides to animals like lizards and tortoises. A dam this big is capable of messing up the ocean currents that bathe Europe, disrupting the food chain not just inside the dam, but outside too. The currents are also responsible for the climate of coastal areas. The Gulf Stream, for example, is a warm current that comes all the way from Mexico and makes the weather in northwestern Europe a bit more bearable. If the Gulf Stream got interrupted by a gigantic oceanic barrier, it could make parts of Europe even colder. Another problem is that the North Sea would turn into a gigantic freshwater lake. This would happen because the saltwater that used to flow from the ocean would now be blocked. And the North Sea would only be fed by the fresh water coming from inside the continent. This process would eventually lead to a thing called desalination, when salt water gets less salty. And it's really terrible because saltwater animals would start to absorb more water than they should, making the cells of their bodies swell. The consequences can be fatal. The disruption of the ocean currents by the dam can also affect the renewal of oxygen in the water. Think of the ocean as a giant recycling system. Surface water needs to sink to deliver oxygen to the deep sea, keeping creatures dwelling at the bottom alive. Without the movement of ocean currents, oxygen would run out and toxic bacteria would take over, creating a poisonous environment for sea creatures. And this is not just a theory. It happened before, 250 million years ago. The ocean got so toxic, it wiped out 95% of marine life and caused a mass extinction. If it's not bad enough, the fishing industry would collapse, and the busiest trading ports of Europe like Rotterdam, Antwerp, and Hamburg would be stuck inside the dam. Sure, we could build sluice gates, but imagine all those traffic jams. The rain patterns of the countries protected by the dam would change too, affecting farming lands and food production. On the other hand, if we do nothing about rising sea levels, permanent flooding could make whole countries disappear. 3 million people on the islands of the Pacific would need to move away by the end of the century. The Maldives would lose 77% of its territories, and cities like Jakarta, Bangladesh, and Lagos would go underwater. Storms would get more dangerous too, destroying treatment plants for sewage and power stations and contaminating farmlands. Rising salt water could also contaminate freshwater supplies, and it's not just happening in Asia and Europe. Philadelphia, for example, is already developing plans to deal with this bleak scenario. This is why the scientists who developed this big red button shaped like a dam don't want people to actually build a dam. They know how bad things can get, which is why they came up with a plan so wild it's basically the engineering version of screaming, "Hey, stop ignoring the planet!" It's a warning. If we don't act now, we'll be stuck building mega dams just to keep our cities from becoming Atlantis 2.0. And let's be honest, nobody wants to live in a future where the apocalypse looks like the deep web version of The Little Mermaid.
Whoa, look at that view. It's a pity about the traffic. Yeah, we'll get a great view from inside the tunnel. What's going on? It's just a traffic jam. I don't know, but it doesn't sound good. Is that water? Yeah. It's probably rainwater. Although it is flowing pretty fast. There's water inside the car! I can't open mine. The water is too strong! Look! Do you see that? The end of the tunnel! We're almost out! The current will carry us out. We're gonna hit in! I'm trying! Help! What happened? Is that our car? That was too close.
Welcome to the virtual helicopter tour. We'll see the most picturesque sights of the city, although this place isn't real, and neither are its citizens.
Oh, wow! What a view! Whoa. It looks like a tsunami is coming!
Oh my cat, you're right. We should get out of here as fast as we can.
Please, tell me that this copter can handle a tsunami?
Don't worry. It's recommended to hide from tsunami waves at a height of at least 130 feet above sea level. And the record height that copters can reach is about 7 miles. Well, at least this city is just a simulation, and no one got hurt.
Hey, where did that fog come from?
It was formed when the wave hit the shore. By the way, the second wave may come soon, and the third one.
Then we should leave. But wait, can't we save those guys on the roof?
Of course. Hey guys, over here! Hurry up!
Seems like I'm safe here.
Nice to see you, honey. We didn't finish talking.
Ah! How did you get here?
You can't hide from me.
Challenge accepted. This roof looks good.
I'm gonna get you. Come on, come to mommy.
Leave me alone!
And speaking of moms, you forgot about my mother's birthday, empty head.
See you never.
Show yourself. Where are my flowers? Where is my gift for Valentine's Day? Why are you so lame?
Whew. Finally. She got lost.
Peekaboo!
Oh well. What a wonderful day. Whoa! Did you see that? That was so epic! Wow! Alright, buddy. No time to think. Steal this car and let's try to survive.
Have you ever seen anything like this?
Not really. Look! The water is very close.
We need to get out of here. Now!
I'm doing my best.
Look out! Ah!
Hey!
Oh,
You okay? I didn't break a single bone.
we need to get to a safe space.
This is it?
Look out! Ah!
Hold on! We'll get out of here, I promise! Let's just try to run away from the waves. Hold on, I have a plan B. Oh no, plan B is canceled.
Whoa!
All right, let's give it a try. Not so fast.
Yeah. We need to get out of here.
I have an idea.
Here we go.
Come here. It's all over. Oh, we're so lucky.
Ava! Another wave!
No, look out!
Ah! It's too strong!
Help me!
This can't be happening! Ava! No! She's not breathing. I'll need to give her CPR. It's 30 compressions in the center of her chest. Then 2 rescue breaths. Come on. I thought I'd lost you.
We can't go back out there.
We'll need to find another way out.
Come on, this way. Stay close.
We need to be careful. We need to get to higher ground.
Oh no, get out of the way!
I'm not giving up. We need to jump. Let's get out of here.
Oh, what a serene morning. Whoa, good heavens! The meteors! Hold on. I need to move, and fast! I don't like this, but hope this route will work. Stay calm, buddy. All right, what's the next step? Seems like it's my only way out. Let's take this path. Ugh, it's about to collapse. The world's falling in on itself. I need to reach fire escape ladder. Hope the worst has passed. Wow, that was a close call, thank heavens. I got to move on. Thank goodness. Oh God, it's falling apart! I'm okay. Gotta move on. What is that, a tsunami? Wow, this is definitely my day.
Ocean waves can grow much bigger than we ever thought and be far more dangerous than we realized. People used to believe that waves only moved in two dimensions, just up and down, like when you draw them on paper. However, a recent study shows that waves are three-dimensional structures, able to move in different directions. This finding indicates that the ocean is more complex than we imagined, and today's ships, wind farms, oil rigs, and other structures near the coast might not be ready for what is coming. First things first, waves break. It might seem obvious, but the truth is that we don't fully understand how and why that happens, and don't know all the steps involved. What we do know is that when waves break, they change shape and become steeper. To better understand this process, researchers initially assumed that waves were two-dimensional. This assumption was necessary because it made it easier to study waves, whether in theory or through computer simulations and experiments. But here's the thing. Saying that waves are two-dimensional doesn't really capture what ocean waves are like. When most people think about waves, they imagine typical, non-threatening waves you see at the beach. But the ones we're talking about here happen in open water and form when waves coming from all different directions meet up. This wild meeting occurs under certain conditions at the ocean, like in a spot where two seas meet, or when winds suddenly change direction, like during a hurricane. When waves from two different directions come together, it creates this three-dimensional wave. To test how these unique waves behave and how they could make the ocean more dangerous for us, two researchers built a special tank, like a giant swimming pool, measuring 82 feet wide and 6.5 feet deep. All around this tank, they installed 168 mechanical paddles. These paddles act like giant hands, pushing the water back and forth to create waves, just like you would if you moved your hand through water in a bathtub. Stop the video and go do that right now. No, wait, I'm kidding. Anyways, the paddles can generate waves of varied sizes and shapes. Plus, they absorb incoming waves so that they don't bounce around the pool and mess up the tests. Beneath the tank, they put 28 huge fans that push water across the tank to simulate ocean currents, mimicking how ocean water moves. Altogether, they circulate around 2,400,000 liters of water in the tank. All of this was done to create a kind of mini-ocean, controlled by some really cool technology. Great! Everything was set, and it was time to test. The experiment has shown us that three-dimensional waves can become twice as steep as two-dimensional waves before breaking. Let me explain. So, the normal waves you see on the beach break when they reach a very steep angle. They have a limit, a maximum steepness, if you will. When that limit is crossed, the wave breaks. So, what this study is telling us is that waves in the open ocean can get as much as 80% steeper than this limit before they start breaking. That also means they can get almost twice as high as normal waves before they start to break. But the researchers found something else that was interesting. Normally, when a wave breaks, it creates a white cap, that foamy part you see on top, and once it breaks, it's done. There's no going back. It's lost its energy. But when these multi-dimensional waves break, there is no white cap. They can only keep growing. That happens because the wave's energy isn't just concentrated in one direction, allowing waves to continue growing even after reaching the steepness limit when they're supposed to break. It's like these three-dimensional waves can redistribute energy and continue building up in the middle of the ocean. That means that together, these waves can grow 4 times steeper and larger than what we previously thought was possible. So, we are talking about bigger, massive waves that can suddenly appear in the middle of the ocean. It sounds scary to say the least. That's why, for our own safety, it's important to understand how this phenomenon occurs. Maybe buildings and homes along the beach aren't at such high risk from this. But these giant waves can pose a bigger threat to things that are in the middle of the sea, like oil rigs, wind farms, and boats. This finding raises significant questions about whether these constructions, as we design them today, are safe and could handle such extreme wave patterns. The thing is, sailors have been trying to warn us about this for centuries. In the 19th century, a French explorer named Jules Dumont d'Urville, well, I gave it a shot. He reported seeing rogue waves over 100 feet high during his voyages. Even though he was very experienced and respected, plus 3 other people confirmed that it had indeed happened, his story was discredited. Like this account, all other stories about massive and wild waves in the middle of the ocean were dismissed as myths, just tales sailors told to make their adventures sound more exciting. Hey, don't we all? Scientists only started taking these reports seriously in 1995, when a rogue wave was finally measured for the first time. The terrifying event happened at a gas platform in the North Sea, about 100 miles off the coast of Norway. The structure was built to withstand a wave of 64 feet, and even then, they thought a wave that big would only happen once every 10,000 years. But they definitely weren't ready for what happened on New Year's Day, when a monstrous 85-foot wave, 21 feet taller than predicted, hit the platform. In a more recent case from 2018, 8 men were on a 61-foot fishing vessel over 400 miles northeast of Hawaii's Big Island, when they suddenly got hit by a pair of rogue waves. One hit the back of the boat, and the other slammed into the side. It was too much to handle. A lot of water came over the top, flooding the boat and pulling it down to the depths. The crew had to abandon the ship and get into a lifeboat immediately. Thankfully, they were all rescued with no injuries at all. These are just a few examples showing that our current oil platforms and ships might not be prepared for massive rogue waves. That's why experts suggest that one solution could be for ship designers to make ships strong enough to withstand double the significant wave height. However, they'd probably need some convincing because of the increased costs. So, here is a pretty convincing fact. It's believed that between 2011 and 2018, 210 waves of this type were recorded around the world, but it's very likely that the real number is much higher. What triggers rogue waves is still somewhat of a mystery, but we know they are not caused by movement on the seabed. Instead, they seem to be more related to bad weather. In Tampa Bay, for example, most rogue waves come in from the west, especially when it's stormy or windy. But we can't say this is the main cause everywhere in the world, as experts believe there could be several other factors at play. What is really concerning is that rogue waves can strike without warning. The open sea can be completely calm when suddenly the whole scene turns into a fight for survival. So, can we actually predict this phenomenon? It looks like we can. In a very recent study, researchers created a computer system that uses measurements from buoys to predict unusually large waves 5 minutes before they happen. It can catch about 3 out of 4 rogue waves. While the system does have some false alarms, the researchers say that from a safety standpoint, knowing a rogue wave might happen is better than not knowing. And I think we can all agree on that.